In this video, we're going to look at identifying functions. So on the first slide, you have some vocabulary words: domain, range, relations, functions. Our main focus, though, is looking at identifying functions in ordered pairs, tables, mapping diagrams, and graphs. The first ones we're going to look at are the ordered pairs. And if you see here, for the ordered pairs, we're going to focus, as it says here, circle the x values and cross out any repeats. So you can see here the x values are circled. If you notice, none of these x values repeat. And since none of the x values repeat, that makes this a function. Okay, so remember, as it says here, x value does not repeat. When we look at the function, or the not function, over here, again, we have the x values circled, and we crossed out any repeats. You can see the -1s repeated and the 2's repeated. So since that's the case, this is not a function. So x value repeats, the y's are different when the x's repeat, so not a function. That is how you tell from an ordered pair if it's a function or not. You look at the x values. If they do not repeat, it's a function. If they repeat, then it is not a function. The next representation we're going to look at is functions from a table. Again, we focus on the x values. You can see they are all circled here on the left. None of the x values repeat, which means this is a function. So x value does not repeat, it is a function, similar to the ordered pairs. And then we look at the second table, and we notice on the x values, the 1's repeat, and since the 1's repeat, we also want to check the y's, that they don't repeat as well for those x values. And since the y values are different for the repeating x values, then this is not a function. For the third representation, we have the mapping diagram, which is similar to a table because your input is your x, the output is your y. So we look at the x values. None of the x values repeat, but then you also have to look at the second part, which is look for only one arrow coming out of each number. So if you take a look, there's only one arrow here, one arrow here, one arrow here, one arrow here. So no x values repeat, and there is only one line coming out of each of the x values, making it a function. So we look at the not a function side. Again, focus on the x values. Well, when you just look at the x values, it looks like none of them repeat because there's just a 2, a 4, and a 3. But when you look closer and you look at the arrows, there's 2 arrows or 2 lines coming out of the number 2. There's one line coming out of the 4 and one line coming out of the 3. But because the 2 has 2 lines coming from it, that is making it not a function. If looking at the mapping diagram is difficult, then you can also write the ordered pairs. So you can see here 10 and 15 I got from connecting 10 with the 15, 20 and 45, 30 and 25, and 40 and 35. So when I look at that, I can see that none of the x values are repeating, which makes it a function. Similar on the not a function side, if I look at the ordered pairs, 2 and 20, so I have that here. 2 also goes with the 40, 4 goes with 40, and 3 goes with 30. So once I listed those out, if I look closer at the x values from my ordered pairs, I can see that the x's of 2 repeat. And since the x values in the coordinates repeat, that makes it not a function. And for our last representation, the graphs, well, if we look at the function side first, okay, it says that they need to pass a vertical line test. The vertical line can pass through only one point at any given time on the picture. So if we take a look, we do a vertical line, and it only crosses through at one point. If I do it over here, it only passes through one point. Anywhere I draw that vertical line, it should only pass through the picture one time. That will make it a function. So down here, if I do the vertical line, it only passes through one spot. Anywhere I draw that vertical line, it passes through the picture on the graph one time. Now when I look at the not a function graphs, again, I still do the same thing and I do the vertical line test, but this time when I do the vertical line test, if it goes through more than one point, then it's not a function. So let's take a look. So if I drew the vertical line, it passes through here and here. Even if I drew the vertical line over here, it passes through the picture more than one time. It does not matter where you draw the vertical line, but look at the whole picture to make sure it either goes through only one time or more than one time. Only one time it's going to be a function. More than one time it's going to be not a function. All right, so looking at this next picture, I draw the vertical line, it passes through once there, so then we think it is a function. We draw it over here, same thing, it only passes through one time. But when we draw the line over here, it actually passes through a lot of times. Okay, so on a line, it's made up of an infinite, tons and tons of points. So actually, this vertical line test goes through a lot of points. So when you see a vertical line anywhere on the picture, it is not a function, because that means the vertical line test goes through many points. So if I do this on the last one, my vertical line, okay, it only passes through this one point. Over here, it passes through 2 points. So this time, I don't have a solid line, but I do have 2 dots that are stacked vertical with each other. So when you see vertical points on the graph, it is not a function. So vertical straight line, not a function. Vertical points, not a function. So on your graphs, you do the vertical line test. When it passes through only one time, it's a function. When it passes through the picture more than one time, it is not a function. Good luck.